So you tell us.
Okay, so now we'll start.
Okay.
Okay. All right. Good morning,
So,
everyone.
okay.
So, on behalf of Center for Telecommunication Research Group at SLTC, I warmly welcome you all for this tech talk based on machine learning for software testing. So this tech talk will be presented by two guest speakers from Exactpro software company. Brief discussion, brief information about this company will be given by Joseph, and then afterwards, Dr. Rostislav will continue the tech talk. So I will introduce the two guest speakers now. The first guest speaker is Joseph. He is a co-founder and co-CEO of Exactpro. So Joseph started his professional career in 2000 as a software engineer in California-based software development company. For 7 years, he worked as a team lead and a technology architect on projects for a number of US companies. In 2006, Joseph joined a company providing quality assurance services in the financial sector. His extensive software development experience helped him to establish a performance testing department specializing in testing high-load trading system. As a tech lead, Joseph was responsible for developing testing tools and implementing technical solutions for a number of leading exchanges and global investment banks. Joseph also has experience managing a consulting practice with a focus on advanced execution systems. As VP of technology, he was responsible for implementing testing solutions on a number of complex projects for customers worldwide before founding his own technology firm. And our second technical guest speaker of the event is Dr. Rostislav Yavorski. Dr. Rostislav received his PhD from Moscow University and received his master's degree from TU Cologne. In the past, he has worked in Microsoft Research Redmond, US, and he also served as Dean or the Director of School of Computer Science and Robotics, National Research Council, Polytechnic University, Russia. His professional interests include applied mathematics, data science, and formal methods of software engineering. Currently, he works as head of research at Exactpro. So now I would like to invite Joseph to start this session by giving a brief introduction to his company. Over to you, Joseph.
Thank you. Thank you very much for the introduction. And good morning. My name is Joseph Itkin. I'm co-CEO and co-founder of Exact. Rostislav, can we please go to the next slide? Thank you. So Exactpro is a software testing business. We are a specialist firm focused on software testing for mission-critical technology that underpins global financial markets, exchanges, clearinghouses, settlement platforms, market data, risk management systems, regulatory reporting, etc. We work since 2009. Exactpro is headquartered in UK. We have operations in United States, Georgia, Lithuania, and last year we started to grow our business in Sri Lanka. Exactpro currently employs over 700 specialists. We were part of the London Stock Exchange Group for 2.5 years. Exactpro was acquired by the group in 2015, and later our management team bought back the company. So Exactpro operates as an independent business. Can we please go to the next one? Our operations span over multiple countries. We are opening new locations to expand the business. This year, we are adding representative offices in Armenia, Australia, Italy, and United Arab Emirates. Exactpro is an international company that has business development support operating from London, United States, and Japan. Can you please go to the next one? We work with clients in 20 countries, 20 plus countries on all continents, and half of the top 20 global exchange groups are among Exactpro clients. We work with the clients from Australia to South Africa, from North America to Europe. The next one, Exactpro is a well-established business in financial services industry. There are lots of media references to our work, and the thought leadership are produced by Exactpro management and research teams. We are focusing on distributed ledger technology, on complex technology platforms, and on introducing artificial intelligence into financial services and also into software testing. Can you please go to the next one? There are many case studies and press releases available in the public domain on Exactpro website in particular. So we have a description of our work with colleagues from Sri Lanka on introducing the test harness and testing framework for Johannesburg Stock Exchange in collaboration with Millennium Exchange and NASDAQ RTS clearing platform. We have information and interview describing our involvement in Australian Securities Exchange derivatives program, in our consultancy services for Hong Kong exchanges and clearing, and our involvement with other companies. Can you please go to the next one? Some of our recent projects. Exactpro helped to launch the fastest growing equity market in North America, MEMEX, or Members Exchange. It is a very prominent project that went live very recently. And if you look at the stats on the equity trading share, we can see that it is growing very fast and becoming the fastest growing market. Another interesting project, can you please go to the next slide, is our collaboration with Airbus Skytra that was working on the trading system to trade, to enable hedging the price of the airline tickets going forward. So we helped them to build software testing for derivatives platform based on NASDAQ technology. Can you please go to the next one? The next one is a project, bonds trading platform, that went live, I would say, less than 2 weeks ago in United Kingdom. It is a technology based on, this technology was developed by our colleagues in Sri Lanka, Yala Labs, and it also uses distributed ledger technology provided by R3 Corda. So this is a very innovative trading platform, a distributed matching engine that we were able to support, working in close collaboration with Free and Yala Labs, a company also based in Sri Lanka. Can you please go to the next one? So Exactpro work received multiple awards in relation to operational resiliency, to our managed services, and also for our key specialists and managers. For example, for the head of our global exchanges division, global exchanges division is responsible for the work that we do with most of the exchanges, and we are working on inviting more specialists in Colombo to support activity of the global exchanges and other divisions. And the next one. So last year, Exactpro started to expand our footprint, and we've opened the new delivery location in Colombo. It is located in the Parkland building. We currently operate on a single floor for 80 specialists, but we are growing very fast. So we've already confirmed and now are in the process of rebuilding 3 additional floors. So we expect to be able to build the team of several hundred specialists working on software testing and AI testing by the end of 2023. Can we please go to the next one? Yes, so this is the Parkland building. And we are trying to work with universities in Sri Lanka to start both research and education projects, as we intend to build a very substantial presence in the country to support Exactpro's international clients. Thank you very much for the opportunity to present Exactpro, and I am very much looking forward for cooperation in the future. Thank you.
Thank you very much, Yossi, for joining us and for the introduction. So I will just continue the same presentation, and I will speak about AI testing research at Exactpro. And at the end of my talk, you will be able to ask questions to me, to Yossi, and we will have time for discussion, I assume. So first thing to tell you, I want to tell is just to maybe speak a little bit about what is software testing research, especially industrial research. And since you notice that I have quite big experience in both academia and universities and industry, let me stress out that industrial research is quite different from what you have usually in university. And there are several reasons. First of all, every commercial company is really focused on generating some income and profit. So the requirements, the expectations is that all of our research will be finally applied to very specific projects, to our clients, client projects, so that will really contribute some new tools, new methods, new approaches, which finally will help us to grow and to improve our business. And second is the team structure. So usually in university, in academia, you have kind of dedicated group which works on some specific topics or project. In industry, it's usually different. And my experience in Microsoft research was quite similar. That usually have quite few people who are kind of dedicated researchers, because most of projects are mixed. So you have people from products, from developers and testers who work on clients projects, and researchers are just part of the team. So we work together to generate ideas, to build prototypes, and then finally, if it's successful, to write papers. So this you should keep in mind, that industrial research is very much focused on applications, and that's really important. So this slide about typical, I'm not sure if it's really complete, but I tried to be as complete as possible to mention all the research areas which are interesting for us. And let's go one by one. So the first block is about anomaly detection. And it's quite kind of expected that software testing company would be interested in anomaly detection, because anomaly is something which is not usual, not typical, and usually bug is again something not usual, not typical. Passive testing is very important currently, because we work with high-load industrial systems, and it's really you should understand that if you try to put this system into some specific environment, or just maybe instrumented with some specific tools, then it will be already different system, because current systems are. So the idea of passive testing is to test by observation. So you just observe a system, you observe it's a kind of normal behavior in normal environment, and then you try to figure that something is going wrong. And this is what we call passive testing. Non-functional testing is another very important area for us. It's usually about performance testing, but also other non-functional requirements too. Test execution analytics is another focus of anomaly detection, because we have, usually we have like 10,000 or so different automated tests for a specific module, and you cannot figure out manually if something just goes not completely wrong. If you get an exception or test fail, then you clearly will see it immediately. But sometimes you have some small deviation in performance, or in some maybe return parameters, then it's hardly possible to figure out this deviation just with manual analysis. So applying anomaly detection techniques to text execution results and system log analysis is a very important part of our job. And there are a lot of interesting research questions and challenges in this area. So if you are interested in this topic, just let us know, and we will try to organize a joint collaborative project. The second important area, it's quite currently it's on the edge maybe of research in software engineering, software testing, is related to natural language processing. And there are two subdirections. The first topic is about spec analysis. So it's quite well known to everyone who has experience in software development that usually bugs are originated in the specification. So if your specification is incomplete, is written in a non-clear language, then you know, it's not one person who develops a system. You have a team, usually it's a distributed team. And if your specification is not good, then definitely one developer will understand it one way, the other developer will understand it the other way, and you will immediately get some inconsistency in interfaces, in whatever. So spec analysis is quite important part of quality assurance now. And again, there are quite many interesting topics to research. And another subdirection is BART reporting automation. So once we created automated tests and found some bugs, then you need to submit this bug to the system so that developers can fix it. And again, like me, like many of the testers, we are not native English speakers. So it may happen that you just describe this bug is not, your description is not really clear, and there could be another issue that developer doesn't really understand what's going on. So analysis, automated analysis of bug reports is also a quite important topic. Another interesting topic related to AI is formula verification, especially if you speak about blockchain technology and related topics. Because for those who know something about formula verification, this technique requires quite much resource and time, and usually, and also it requires access to source code of your application. And usually we don't have neither much time and resource, not access to the source code of the system. But if you speak about smart contracts on blockchain, the situation is different. First of all, smart contracts usually are not that big, like maybe 1-2 pages, not more. Second, usually it's not the problem to provide access to the source code. And the third reason is that smart contract is a piece of code which manages a huge amount of money. So the risk of bug is quite huge. So applying formal verification, like runtime verification, model checking, other methods is also quite popular here. And this is another kind of rising topic of research. Model-based testing is quite well known in this era, but again, still model-based testing is more art than technology, because okay, just simple example. Once you have quite a huge industrial system, either you try to build your model as good as better as you can, then it becomes huge and hardly manageable, and very similar to your application. I mean, similar in size and complexity in whatever. Or you try to build a simple model like using finite automata or maybe pattern nets. Then your model is quite small and nice, but you know the level of abstraction is completely different. So to build a really useful formal model of a system which could be used for test generation, test selection, is still quite tricky. So there are quite many interesting questions here. So if you're interested in modeling, okay, please contact us. We will be happy to work together. And the last but not the least block here is testing of AI-based systems, which are everywhere now. And this is completely new area, which we work on already. And I will speak about it a little bit later. So every item here is interesting for us, but maybe something else too, but at least these topics are definitely of the interest. So before I go maybe to some examples, let me share some proud example I'm proud of about our recent achievements. And definitely this one might be the best on my resume so far. So last year in September, Swift, I assume you should know what Swift is. It's kind of international organization who rules all the money in the world. So Swift organized a hackathon with 2 challenges. One was about enhancing the accuracy of anomaly detection in payments. And we were quite good in this challenge too, but not the winners. And the second challenge was building synthetic data sets required for AI-based product development. It was protecting privacy, and we came second. And this is really a great achievement for us. And our research team was really part of this work. So that was quite impressive for us. Then second is again previous year, another event which was dedicated to autonomous driving AI test challenge. And this time we were co-organizers together with IEEE, Baidu, LG, and other famous organizations in the engineering world. And again, we have quite we have several lectures on the web related to this topic, so you can just find and see. Okay, and the third point is TH2. It's our platform which we use for actually almost all our clients. And TH stands for test harness of the second generation. And the source code of this tool is currently on GitHub. So it's open source, and any of you can access it. And we are working hard to make the documentation complete and clear, so like everyone can just try and use it for study, for research, for applications. Okay, let's speak now about challenges of AI testing, and let me start from some quotation from Bank of England. And this analysis was published like a couple of years ago, and it states that machine learning in financial organizations already passed an initial development phase, and the usage of LiveML application is about to dramatically increase over the next 3 years. So, and on the right, you can see just some short list of applications which already use machine learning inside. The first is market surveillance system. Second is conversational assistants, which are very popular in financial world. Then algo trading systems, again, which are very popular among traders, and other examples too. So let's go one by one. And the first example is market surveillance system. And the idea is quite old. So the rules of trading are very simple, right? So one party suggests some bid offer, then another party suggests some sell offer, then you match them, and then you figure out, okay, you get the trade. But the problem is that some people use this very simple and very useful scenario for some malicious purposes, and these guys could be quite tricky. So there are quite many already known scenarios which could be used, for example, for money laundering or for other forbidden scenarios. And the goal of market surveillance systems is to help exchange in maintaining orderly market, so that all the events have to be analyzed. And you should understand there are like millions of transactions during one day. So monitoring all these transactions to figure out all these hidden, possibly malicious scenarios is quite a difficult task and quite challenging problem. And again, it hardly could be done online. So usually it's done on the logs. So you store all the information after the day trading, then you try usually overnight or maybe spend a couple of days fully automatically and applying all possible algorithms from machine learning, data science, whatever, to figure out some anomalies, some suspected trades. Then you generate this list like of candidates, which then finally will be analyzed by human, by professional, who will finally decide whether this kind of behavior is okay or is it malicious. So market surveillance systems, surely they have some artificial intelligence and machine learning inside, and development of such systems is quite a tricky task, but testing such system is another tricky task. So we have already a project with some client on testing market surveillance system, and this is a very interesting project. So this is just a good example of our work. Okay, next quite known example of AI-based system is a conversational assistant. Okay, now almost everyone has this kind of assistant on his or her phone, but as I mentioned already, this is a very popular tool among banks and other financial organizations, because the idea is to keep privacy. So once you don't have any bank employee in the middle, the chances that your information will leak is much lower. But the implementation of such conversational assistants has a lot of challenges, which are mentioned on the right. So let's read some example of conversations. Like a client can ask the assistant to submit an order, to set up some alert notification, to make a transaction, and this is more or less a simple example, right? Then second item is about question answering, and this quite typical scenario of using this kind of assistance is when a client tries to ask some questions, which he or she usually asks from the bank manager, but now one can try to use the assistant to communicate, and this is a typical example, like when do you use MT507 whatever message, or how to change system password. So you see there's just natural language, and different people can use different form of asking this kind of question. So your system need to figure out what's really the intention. And the third item is chit chat, and here's just a simple example, like Siri, my brother says that all robots are stupid. It's not me, it's him. And your conversational assistant needs to be polite, needs to figure somehow what to answer in this case. And that's not that simple task to make this conversation still correct. So the fourth item just lists some typical issues, typical challenges that you have when developing this kind of applications, like focus switching. So a person can talk about one topic and then suddenly switch to a different topic, then switch back to previous one. And that's okay. For humans, it's quite okay to keep this kind of conversation. But for example, currently can just look to the right, say, okay, today weather is okay, and then return back to topic of AI testing. But for conversational assistants, this kind of scenario is quite difficult. So another issue is intent detection, like I said, to figure out what really the client wants. Then mixed initiatives, recognition of emotions, maintaining context, and personalization is also very important, because different people prefer different styles of communication, and your assistant needs to kind of follow this style. And again, everything I just mentioned is about development of such assistants, and then you have the task of testing. So you need to develop different test cases to check all the items I mentioned. So you need specific tools, you need specific criteria like coverage or whatever. So testing conversational assistants is quite a challenge now. So any ideas, any research here is welcome. So this slide is quite important too, just to indicate that usually if you speak about AI-based system, especially for engineers, for researchers, the ML model is the most interesting part. And we usually speak about these machine learning algorithms and tools and etc. But in industry, the customer is interested in the quality of the whole system. We call it end-to-end quality. So, and the system doesn't consist of ML module only. So you have a module which is responsible for data collection, for data verification, for management, different resources, for infrastructure, etc., etc. So each of these modules needs to be tested separately. And in addition, you need to perform system testing to check that all the communication, all the integration works too. And this becomes really a challenge because, okay, we'll speak about it later, but you can imagine that this system could be complex. The interactions could be quite complicated. And again, design a good tests, even automated tests. So you can run quite, well, maybe thousands, millions of different tests, but still it may happen that some particular module inside is not touched at all. So designing a good test with good coverage is another issue for such a huge complex systems. Okay, so let's summarize this part. This is the list of challenges from AI testing syllabus, which is kind of recognized, internationally recognized body. And you see this list that what are the challenges of AI testing system? So the change is unexpected and the behavior modifications are undesirable. So environment is complex and acceptance criteria are complex too. Resources are also always insufficient. Testing time is insufficient, specification is insufficient, and all the exams which are listed here, like client trading, clearing, market surveillance systems, distributed ledger technology and blockchain platforms, smart contracts, auctions, they all like that. So you see the field for applying different kind of research is huge and not easy. Just to summarize, so all our systems we try to test, we really test non-deterministic. And you should understand that's really an issue for testers, because once you found a bug, you try to submit it, developers try to reproduce it, but the system is non-deterministic. It means that it might happen that your bug will not reproduce easily. So you need to try many times in order to figure out this particular scenario. So they are probabilistic, non-testable, and another issue is ORAC problem. You probably know that in classical testing, you describe test case as input data and expected output, right? So you, for example, you are testing some calculator, you need to check it for input values like 2 and 3, and expected result 2 plus 3 equals 5. But for non-deterministic, non-testable and probabilistic system, you usually don't know the expected result. This is called co-ORAC problem, and this is another issue. So it's not that easy to describe expected behavior. So we go back to the notion of the task of anomaly detection. So you might try to describe normal behavior and abnormal, but exact output, exact oracle is not possible here. Okay, so questions are welcome slightly bit later, but I hope you will ask something. And before I conclude, I was asked to suggest maybe some topics for students, for researchers to start with. And here are two. And surely the first one is anomaly detection. So again, the problem that there is no precise definition of what anomaly is, because in order to define the anomaly, you need to first define what's normal behavior. And then anomaly is deviation, exception, or maybe some rare occurrence of event according to definition of your normal behavior. And you should understand that normal behavior highly depends, for example, on your project domain, because in some applications this is normal, and in other application this is not normal at all. I mean, like different performance. For example, it's okay if you use like cell phone and some operation takes you maybe like 1 second, then maybe for this application is okay, maybe for front end application. But if you're working with backend module, then performing 1 operation per second is something not definitely acceptable. So this is one example. Second, even worse, that anomaly, the notion of anomaly can change over time. Consider a simple example. Okay, in Sri Lanka, you always have summer, but in other locations of the world, sometimes we have winter, and assume we have snow today. So during summertime, snow is definitely an anomaly, right? Because weather should be hot. Okay, it's okay to expect some rain, but not snow. So, but then winter comes, and during winter, snow is not anomaly at all. So you see, the notion of anomaly can change over time. It depends on the domain. It's very difficult to define, but still we need to find all these anomalies. Especially anomalies are very interesting for performance testing. Like I mentioned, so you see quite different graphs, different behaviors, and to figure out that at this point system behaves quite in a slightly different way is very important task and typical task for us. And if you would like this this topic, surely you can start with reading our article, or surely there are a lot of different resources on the web. But this is published by IEEE several years ago about one of our projects on anomaly detection from log analysis. And there are several open data sets on this topic. Most of them are on Kaggle. I like Kaggle, and I hope you like Kaggle too. So this data set is about software defect prediction. It has 10,000 modules created by NASA, National Aeronautic and Space Agency of United States. And you see it has quite low dimension, only 22 parameters, 22 attributes, like different size, different metrics like essential complexity, design complexity, systematic complexity of the code, different measures like volume, length, difficulty, intelligence, etc. So you have these 22 parameters of the piece of code, and then the task is to predict some number of defects, whatever. And if you like really big data, big data, then I suggest you to play with the other open data set, which is about monitoring of quite typical enterprise application. And this is not a joke. This data set really has 27,000 files, and total number of parameters, which is actually the dimension of your system, is 4 million. So for theoretical, from guys who work in theory, it could be quite impressive. But in real industrial applications, this is quite typical size. Like you have like 27, you have like maybe 1,000 computers running in your system, and each computer runs like 27, 20, 30 or 100 different modules. That's not many, and each module has maybe like 100 parameters. So the dimension of the whole system is quite several million. And again, the goal is to figure out some anomalies in this behavior. And just to repeat again, so these data sets are open, so you need nothing to start playing with this. But if you are interested in working with us, surely we can provide you access to our client's data, but definitely we'll need maybe to sign some agreement first, maybe NDA or something like that, and surely we will be happy to involve you too into our projects. But these two examples are just free, so you can start doing something to discuss, to develop maybe some tools, ideas. You can start immediately. So the first topic is anomaly detection. It's very interesting, and everyone is welcome. So the second is related to natural language processing. And like I mentioned, there are two sub-directions. The first one is related to bug reports. So, and here's some typical question. The first question is a readability assessment. I already mentioned this. Second is quite important too, is the application detection. So usually in every system which is quite maybe at least several years on the market, the number of submitted bugs is could be like 10,000. Surely not of them are critical, but still all these bugs are already in the system, and then some new feature is developed, so some new tester is hired. So this tester found some bug. He or she tries to submit it, and it really may happen that this bug is already in the system. So it's not really good to have some the same description, different description of the same bug in the system. So to figure, but again, this description could be done in completely different words with completely different screenshots and completely different examples. So it's not that easy to detect that this bug description is actually description of the same bug we had like last year. Okay, then the third item is automatic fault localizations. So again, in your systems, like I mentioned, you have numerous different modules, and sometimes it's quite simple to figure out that this bug is definitely from this module, but sometimes it's not, especially if it's integration bug. So each system works more or less okay, but if you try to integrate them, then you get some scenario, for example, some inconsistency in interface, whatever. So to figure out which developer will have to fix this bug, which is called a fault localization, is not easy, and definitely some tools would be helpful here. Again, I guess, and similarly bug assignment. Determining bug severity is another topic, and the last one is bug prediction. This is what usually managers like, because again, you have many people, many teams involved in the development, and the manager needs to predict whether the development is under control, whether we hit the timetable, deadlines, whatever. So fixing time prediction is another important question, which could be solved using machine learning and AI techniques on bug reports, on dataset of bug reports. And another interesting topic which I mentioned is requirements text analysis. There are quite many questions too, like detecting linguistic issues, evaluation the sufficiency of information, the completeness. Some publications, I already seen some research on automated test generation from requirements. That would be really great, but okay, not maybe in this generation. So extracting models from not complete models, but at least some maybe modeling concepts from the specification, and transforming natural language description into formal specification is another quite interesting topic. And again, here are some already publications by our team and surely by many other teams about raising the quality of bug reports by predicting software defect indicators, which is again published by IEEE. You can access this paper and contact us if you have some questions and ideas how to improve this. And surely there are some open data set on Kaggle, for example, bug data for Google Chromium. And you see, this is just a quote from the site, which is completely corresponds to what I am trying, to the message I'm trying to give you, that the major challenge is that bug description usually contains a combination of free unstructured text, of code snippets, and stack trace, making the input data highly noisy. So it's really a challenge to work with bug reports, but recent advance in the natural language processing tool makes it quite possible. And you see some example here. So this is quite typical example of bug reports. We have like owner here, then issue type, and then quite detailed description that if you go this kind of steps on this product version under this configuration, then this and this might result in such unexpected behavior. So to conclude, I'll just show you the same list. So you see all the challenge of testing AI applications is really big, quite many interesting tasks. So each of them is very interesting to maybe particular client or maybe a group of clients here. So we already have some experience in each of the topics. So if you're interested in any of these topics or maybe something related to this, you'll be happy to collaborate. And also, as Yosif already mentioned, besides research collaboration, we're also interested in doing some joint educational programs, maybe summer school or maybe some special module or whatever. So let's discuss, let's do it together. So that's all I have for today. Thank you for your attention. Questions, comments, welcome. We still have some time for discussion before the next talk. Are you still here?
Thank you very much, Dr. Rostislav. Now it's time for the questions. If you have any questions, you can ask. I think SLTC for academics, we have other technical sessions line up after this one. For students who have joined right now, you can ask questions with the, based on these research topics of interest, whether sometimes maybe you can work on this topic for your master's or bachelor's degree programs as well. And if you are keen to know like some additional information, you can now discuss with Dr. Rostislav and ask, then we can kind of like we can give you official linkage with the company.
But again, if you are shy and don't want to do it publicly, you can write me and we can establish a meeting. So I understand that maybe there's too much information for today. So I send my presentation to Tarindo. So I hope he will distribute it. So you will have access to the slides and to my contacts too. I hope he will share with you. So write to me, write to Yosif, but if you have maybe at least comment now, I will really appreciate.
Hello, Doctor. Can you hear me?
Yes.
Yeah, thanks for the presentation. Yeah, that's actually very much informative session, and that actually gives a huge idea about software testing and all the industrial perspective. And my question is not directly related to software testing, but I was working with this anomaly detection, where we were working for this COVID-19 data anomaly detection using some time series informations and all. And we were using some array, some statistical models, actually ARIMA and some other related models. And the thing that the challenge that we had is when we use it for a country base and for a continent base, some of the characteristics are hidden, right? It's kind of rare for a particular country, and it is not common for other countries. And those kind of hidden informations are there when we take the results in the anomaly detection. For example, for a country, it says anomaly. For another country, it is not anomaly. And when we go for a general model, it's kind of some anomalies are avoided. And it's how we can use this kind of a general model where is there any way to condition on something or any other way that you can propose on working on this kind of general models?
Okay, thank you for quite interesting question. Since we are short of time, I will try to be very brief. So like you said, you're right. There are two different approaches, either statistical methods of anomaly detection or machine learning based. But according to my experience, it completely corresponds to what you're saying. At least 80% of time, maybe sometimes 90% times, every data scientist spends not on building models and figuring out the results, but on cleaning and normalizing data. That's really the issue, because you almost never have like ideal data set. So I completely understand your feelings that you would really prefer to have complete data from all the countries, which is clean and correct, but that's the life. So almost never we have perfect data set. So it really takes huge time to figure out what we'll do with this particular missing value, what we'll do with this particular outlier. So, and usually the answer is very much domain related. So you cannot do it just statistically. Okay, we apply this tool and we mark this out. So you really need to understand what's going on in your application, and then to make some decisions, which is again never perfect. But really a nice project, so I will be happy to discuss it maybe next time. Thank you.
Yeah, thanks a lot, Doctor. And also add something to it. Some researchers do something like this in order to improve their models. Kind of they use something synthetic data generators, kind of GAN or conditional GAN, something like that, and they take some parameters and some produce some synthetic data, generative adversarial networks or kind of related networks, and they produce some synthetic data and they add into that data and they claim it actually improves the system. But for me, it didn't work. And is there any way that having generating synthetic data might help in improving the performance of the system?
You know, that's maybe if you find maybe a couple of more friends who are interested in this topic, I suggest maybe organizing a separate session on anomaly detection, because this is really a huge topic. And I have also some colleagues and friends who are working on that. We can make a separate workshop on anomaly detection. That would be very interesting, definitely.
Sure, Doc. Yeah. Sure. Thank you. Thanks a lot.
Okay, thank you, Tarindo. I really like perfect timing, so like 1 minute to finish.
And also, Dr. Rostislav, there's one question in the chat box.
Let me read. Okay, so I should open chat.
Yeah, you can stop sharing.
Yes, I have one question. I can stop sharing. Question. Other online website to obtain datasets to train the ML model. Also, can you generate your own datasets? Can use an Excel file? Do we need to use other tools? Also, how much data do you need to train sufficient? Of too many questions, but let me be brief and try. So how much data? It usually application dependent, but there is some magic number, which is 10,000. So if you have less than 10,000 data units, then definitely it will be difficult to apply machine learning. If more than 10,000, maybe 1 million is better, it will be okay. Excel file, it depends on the size. For I myself like Excel a lot, but if you have more than 1 million lines, then Excel would be not that good in performance. But otherwise, you can make a kind of some sample, which is much shorter from your data, then play with it in Excel. Because what's good in Excel is that you can see your data, and it's quite important to have this feeling, kind of internal feeling of your data set. So you can start playing with it in Excel, but if it's huge, finally you have to switch to Python or something else. Generating your own data sets depend on application domain. For example, if you for example, creating an algorithm which will play chess, for example, or play any other computer game, then you can easily generate reasonable artificial data. In other domains, creating artificial data is quite tricky, and so that's not that easy. Online websites to obtain data sets. So Kaggle is the best probably resource with open data, but there are other sources too. So okay, I try to be short and in time. So hopefully my answers are useful. Thank you for the question.
Yeah, thank you very much, Dr. Rostislav. Now I think we can wind up this session for time being. So thank you very much for everyone for participating in this event as well. So we will hope we will have some other technical discussions and well as some workshops organized in future, maybe for undergraduate student, postgraduate student, as well as the academic staff of our SLTC. So thank you very much, everyone. Have a nice day.